Period is the time it takes for the wave to complete one complete cycle. And anything can be periodic. Any motion that repeats itself over and over again is called periodic motion. Earth going around the sun, it's a periodic motion. That period is 365 days. The Earth spinning, that's a periodic motion. The period for that is 24 hours. Any time that the object is in repetition, and you can calculate a period, it's the time it takes for one of those cycles to be completed. For a wave, up, down, up represents a period. That's one cycle of a wave. How long did that cycle take? It's the period. The period is related to frequency by 1 over f. Period is 1 over f, and if you wrote it a different way, frequency is 1 over period. So once you know the period, you know the frequency. Once you know the frequency, you know the period. Period is a time, so it's given in seconds. Frequency is the inverse of that, so it's seconds inverse. We also use the unit of hertz to represent frequency. If you've ever bought a computer or looked at the specifications on a computer, the processors work at 3 gigahertz. That means they're performing 3 billion calculations every second. They're cycling 3 billion times in a second. That's pretty quick. Waves that we're talking about, light waves, are pretty quick. Some frequencies can be very fast, some frequencies can be very short. Same thing with periods. So any number is legitimate for those values. Not negative. They're always going to be positive. You can't have negative time, so you can't have negative periods. So just as an example going through, sound travels approximately 340 meters per second. That's true. Sound waves travel about that speed. They're temperature dependent. We'll do a lab on that later on. But the hotter it is, the faster that sound moves. The colder it is, the slower that sound moves. At room temperature, it's approximately 340 meters per second. So if the sound of the thunder arrives 2 seconds after the lightning is seen, how far away is the lightning? Lightning? Here. That lightning goes boom, and sound travels at a speed of roughly 340 meters per second towards the ear. If you hear it 2 seconds later, how far away is it? Distance traveled over time, velocity is 340 meters per second. Distance it travels in 2 seconds, 680 meters. Okay, third of a mile. Or what's a mile? 1,600 meters? About a third. A little more than a third of a mile. So that's an example of how you'd use velocity in order to calculate distance or speed of a wave. Oops. Everybody got your clickers?